Hello and welcome back to the channel. In a recent video I was talking about the bootloader and setting up a multi-booting system, and well, in the boot directory, what are these files? So I found that these files look like Windows binaries, and are these Windows binaries, and if they are, what the hell are they doing there? But before I go into today's deep dive with these files, why don't you consider subscribing to this channel so you will be notified when new Linux related videos are coming up. So let's dive into this topic. What are those files doing there? So if we take a look at Wikipedia, and especially the executable page, which is, well, executable code or executable file is talking about. So we want to consider kind of what are those binary files, and here in this Wikipedia we get a very concise description. It shows us like a kind of a hex dump of an executable, and if you have ever run Windows and Linux, you know that if you have an executable file on your Windows system, it is not really easy to run that executable file on Linux. It's natively it's impossible. There are some workarounds, of course, but generally the Linux kernel cannot start a Windows executable, and if it comes to the Linux executables, your Windows computer cannot run those. Why are those? So basically, if we are thinking about binary files, at least what we learn about the basics of the binary executables, usually when we start learning some things about computers, is basically that there are these binary codes which correspond to some kind of instruction on the CPU. But if the CPU is following these binary instructions, then why is it that I cannot run a Windows program on my Linux operating system if the processor is the same? How does it even work? And also vice versa, why cannot I just run a Linux executable on my Windows computer? And so those of you who are more well versed in this kind of field, or maybe tried out different Linux distributions, you will also find that sometimes you cannot really run the same executable binary on like a different distribution. So you always have to try to get the proper files that are compiled for your distribution. So what's going on there? And so basically, to answer the first question is we can go to this comparison table, and we can see that there are many different executable formats, like what is this, Flex OS, CP/M 68K, COM, CP/M, COM DOS, MZ DOS, MZ, NE, LE, and so on and so forth. And here you can see that what kind of different operating systems have been using this kind of executable file formats. And so basically what is happening when you run this kind of binary programs, that they are loaded by a suitable executable loader, and then we'll be able to see this will be directly executed by the CPU. So of course these executable files are not just sent to the CPU directly, so that's why it is kind of have a kind of a format. So the Linux operating systems and the most like the Unix like operating systems like this ELF, executable and linkable format for their binaries. It contains like object code, shared libraries, and even core dumps are saved in this kind of ELF format. And this is from the Unix operating system named System V Release 4. And well, this has a specific layout which we can check on this figure, and So basically has some kind of header information, some kind of different sections, and well, yeah, this is kind of complicated program header table. Basically, what we have to consider that on the modern computers, these executables are loaded to the memory, and basically depending on what other programs are running and what is going on in your system, these executables will be always loaded to kind of different segments of the memory. So when these executables are referencing some data, that data always be somewhere else in the in your memory, in your RAM. So basically that's one of the things that these binaries have to be able to do. And so why do we have this kind of Windows icon? So this VM Linux-Linux-LTS and VM Linux-Linux, why are they appearing as the Windows executables where we just talked about that Linux has its own format, and even grub comes in this Windows executable type format. And so the answer to that is, if we go to the portable executable section on Wikipedia, which is basically this is what Windows uses for executables, DLLs, etc. And what is interesting is that the extensible firmware interface specification states that PE is the standard executable format in EFI environments. So if your computer has an EFI system on it, then this is the type of executable that you have to use. So even if your operating system uses the ELF format to run its own code, then even in that case, basically this PE format has to be used so it can be loaded by the EFI, and your bootloader and your kernel can start up. So basically this is why we get that. So here you can see that in EFI firmware use portable executable files as well as the Windows ABI calling convention for applications. So we cannot do anything about this, even though a lot of people think that the ELF is a superior format. I don't have an opinion on it, I'm not an expert on it, but we still have to live with some of these PE type binaries, just because this is the EFI specification for executables that can be executed by the extendable firmware interface. And so if just Linux uses this executable and linkable format, what is the deal with the different distributions? Why do we need different executables for the same program on different distributions? And for that, this Quora answer is actually very interesting, from like 5 years ago, but it is basically the same. So the thing is that this ELF format is a linkable format, and it will use a lot of binaries linked together. So when you write a code, you will probably use someone's previous work and link those dependencies, and those dependencies can be, different names, can have different locations on the file system. So basically each Linux distribution is its own operating system with its own conventions, with its own package database. So that's why you need to have these on different Linux distributions will have to have the different binaries. And so if you take a look at this Stack Overflow answer, for example, is that so basically the libraries can be like statically linked, which means that all the libraries that you used is basically inside your executable file, but this will bloat the memory usage. And the programs that only use standard libraries, then you have to build everything from scratch, and it's probably for any complex task is not possible. So this is kind of the problem, and of course this can lead to this concept called the dependency hell, where all these libraries that should be linked by the application when running, they have some problem. So what is the problem? So there can be a lot of problems, and mostly what is important is that we can have this kind of conflicting dependencies if we are not careful. So for example, here they say that if the one application depends on the 1.2 of this library and the other application depends on another version of this library, then usually you should have both of these versions, and these applications should specify which one to link. But in your usual Linux distributions, this is not really supported. So one package should only contain one version of the library, and each of these applications that use that library should be compiled against the appropriate version. So that is basically the deal with open source software where the source code is available, that the maintainer of the distribution can decide that, okay, our distribution will contain this library from the 1.2 version of this library, and so we will both compile the app1 and app2 to use this library 1.2. And if you don't recompile this program when switching out this library from 1.2 to 1.3, then you will probably face a lot of problems, because in this binary, when all these different kind of, let's think about like the library provides some kind of function, but this kind of function might be at a different address inside the binary once the new version is recompiled. So even if just the same functionality exists in both versions, but there is some kind of debugging happened and some code optimization, it is very possible and very likely that the binary address in the binary file will be different, so it won't work. So that's why in Arch Linux, where we have this rolling release where each and every package gets updated quite often, you always have to update your whole system together, because if you only update this application which wants to use the 1.3 version of the library, but you did not install the new version and you just have the 1.2 version of the library, then it won't work. And so as long as you have free software where you have the source code and you can compile this, or the distribution maintainers can compile it for you before distributing the binary, then this is not a problem. When it is a problem is when you are having like a proprietary software which you don't want, or basically the manufacturer of the software does not want you to have the source code, and that's when this kind of problem with like the Adobe products or Microsoft Office comes into play. That, well, if I don't want to show you my source code, but I want you to be able to use my binaries, then I always have to compile this for the current versions of these libraries that your distribution is providing. So that is one of the basically this is like the fragmentation argument, that because there are so many Linux distributions, Adobe will never compile or never optimize their software for Linux, because if there was only just one distribution, they could just focus on that one and could do it easily, but there are too many distributions. I don't buy it because I don't like proprietary software, of course. And there is, of course, some kind of solution like AppImage and Flatpak and the Snap Snappy or Snapd or whatever this one to solve this problem, kind of similarly as how this person, this Bob Jones, is this Bob Jones's answer? No, the answer is from Emilio. This Bob Jones just edited. So as Emilio says in this comment in Stack Overflow, just basically you can try statically link all the libraries, or what AppImage and all these like Snappy and the Flatpak is doing, that all the dependencies are built into like this compressed file, all in the binary form. This is not just, this is mostly for distributing proprietary software, but sometimes like free software is distributed in this way, like for example the recent debacle about Ubuntu. And so as you can see in this blog post, for example, as kind of complaining about the Ubuntu Snap obsession, because Ubuntu basically only distributes the Chromium browser as a Snap package. And why are they doing this is basically because Ubuntu's release strategy is that they release a new version like every 6 months and every 2 years, and so like 3 of them are just interim releases which are only supported for 8 months, but the like one every 2 years is supported for like, I don't know, I think 5 years maybe. And for business customers, those are supported for even longer, like 10 years if you pay for it, which means that sometimes they can have as much as like 5 concurrent versions of Ubuntu, and each version will have different versions of the packages. And as we saw in the dependency hell page here, so if you want to compile your software, you always have to compile against the libraries that are existing on those systems. And because Ubuntu doesn't want to roll the every package, so they just keep to like a stable version because that is their philosophy. So if they wanted to distribute the Chromium browser just like a standard package, then they would have to compile it against like all the dependencies that are in all their supported Ubuntu versions, and they don't want to do that, so they just use this kind of the statically linked version where they just package all these new dependencies that are needed by Chromium. So basically, instead of releasing the new dependencies as regular packages in an update to the previous versions, what they do is just package up all these new dependencies with the new Chromium version and just distribute it like that. So I don't know what you think about it. I don't really think it's a smart move or I don't, you know, okay, it probably is a smart move if you like consider Ubuntu's business model. So for my use case, it's not really what I like, and that's why I'm not using Ubuntu. But if it's good for you, then why don't you use Ubuntu? You should use Ubuntu if that is the distribution that satisfies you. For me, the Arch philosophy is much more close to how I like my system, because in Arch the developers can always just focus on one release, and that release is always the latest possible release of the software. And basically that way, especially for free software, it is very easy to distribute this, because each new version of the software is always compiled against each new version of the libraries. And so that is why I prefer the rolling release model. So this is the end of this video. If you learned something interesting, then why don't you give me a thumbs up? If you have some comments, disagreements, or questions, then leave them in the comment section down below. And subscribe to this channel if you want to see more, or check out my playlist. And I will see you in the next video. Bye. Bye.